All right, let's try to finish up 7-6. So that's why I called it 7-6b. Let's draw a circle since that's what we're talking about here. And there's a nice circle. And I'm going to draw some things through here. Let's do this. Oops, that's not what I wanted. Let's do that. All right, here we go. Oh, sorry. Let's put the center here. Oops, it's right there. Pretty close. All right, and I am going to draw. Have we talked about this? What is that thing if it goes through the center and it hits both ends of the circle? The diameter. Very good. All right, so that's a diameter. So I'm going to draw some other radii. I'm going to draw one. This may not be exactly to scale, but it should be, oops, it should be pretty close for us. Yep, that's not bad. All right, here's what they do. They want you to find each of these angles if, let me make sure, that's 75, 25 is 100, yep. So if this is 45%, oops, I put degrees, 45% of the circle. You don't actually do these very much. It's kind of surprising that they put this as an example, but that's all right. It still works out. So tell you what, let's do this right here. So this chunk right here is 45% of the whole entire thing, all right? What do we call that chunk, that piece of the pie? It's right in front of you. It's right on the screen.
Sector.
It's a sector. This is a sector. This part right here, I'm not going to shade it in, but see all this stuff right here? That piece of the pie, right? Big old chunk of the pie. Everybody see it? Pizza. I had pizza last night. All right, so big old chunk of that pizza, that's 45% of it. What would it be from this point all the way to this point? What would that sector be? What percent? It'd be half, right? It'd be what? 50%, agreed? So it's a little less than 50%. All right, again, it might not be to scale. This should be probably a little skinnier, but that's okay. So what do you think this percentage is right here then? This is 5%, exactly right. We didn't just guess. We knew it was because this splits it in half, right? So the whole sector would be 50%. If I told you that was 45, that has to be 5. Now, there's no way that we can really tell what each of these are, but if I knew what one of them was, I could find the other one. So if that was 20%, what would this one be right here? This would be 30%. Okay. What I want to do in this example is to find each of the angles. All right. And they didn't do this in the book, but I'm going to. Let's make that look more like an A, B, C, and D. All right. And we'll call this E. So the center is E. Everybody with me? So that 45%, what angle is that? What's the central angle of that sector right there? Angle what? Say it again? BEC, very good. It's angle BEC. This angle right here, that's the angle of the 45% sector. Everybody see it? All right, that's the central angle. What angle is it? It's BEC. Can I just call it angle E? That'd be a lot easier, wouldn't it? Why not? Yeah, there's other angles coming out of E. Exactly right. All right, so I can't just call it E. I got to be specific. I used 3 letters. Just gave a quiz or a test in my CP geometry class. And man, I mean, there were things that were supposed to be sides and they wrote it as angles. It was supposed to be a triangle. They write it as an angle. It's supposed to be an angle. They write it as a triangle. And I'm thinking, I just don't know if they understand what they're actually finding here. But I had some people call an angle just by 2 letters, call it angle BE. Does that make any sense at all to call anything an angle BE? No, it doesn't make any sense at all. All right? This has to be 3 letters, BEC. Everybody with me on that? Okay. So what I want to do is I want to find each of those central angles. So angle BEC, we want to find what that's equal to. Give me the 5%. What do we call that angle? A what? AEB. Okay, I thought you said ABE. AEB. Now notice, the E is always going to be where? In the middle, because that's the vertex of each of these central angles. Agreed? Right? What about the 20%? Which one's that? Angle what? AED. AED. And then the 30%, what's that called? DEC. DEC. All right. What I want to do is I want to find the actual measurement, okay, the actual angle, the degree measure of each of these angles. Not the percentage. I want to find what actual degrees they are. Let me ask you this. What if I started here and I went all the way around to here? How many degrees is that? 360 degrees, that's right. Everybody with me on that? So this angle right here is what percentage of 360? 45%. Everybody see it? So let's say it was 50%. Let's say that whole AEC right there, okay? What do you think the angle would be if it was 50%? 50% is half, isn't it? 0.5, yes? So what's half of what? 360. What's half of 360? It's 180. So that makes sense it's 180, doesn't it? Because that's a straight line. Everybody got that? But this is not half. It's 45%. Or, as BEC, that's this first one, how are we going to write that as a decimal? 45%. I kind of gave you a big hint with the 50%. 0.45, that's right, 0.45. You don't technically need the 0 there, but we'll put it there anyway. So 45% of, what does that mean in math when I say of? What do we do? Something of. It's multiply. It's multiplication. So it's this of what? It's 45% of the whole entire circle, which is 360 degrees. All right? I did the math for you, and that's 162. Does that make sense that it's 162? Sure, because 180 is half of it. 45 is just a little bit less than 180.
I thought there was like
Agree?
another trick you could do, like 45 times, it would be 45 times something, maybe 360 or 45 times.
I don't know. I would just use a calculator. I don't know what the trick is, but I would just use a calculator, all right? And that's what you get. Everybody got it? Okay. Don't put 45 times 360. That's going to give you some big crazy number. Is there any way that this angle is some big crazy number, okay, degrees? No. It's a little less than 180, right? So it should make sense to you. And that's the way geometry should be. You should look at the answer a lot of times, not all the time, but a lot of times you should look at the answer and it should make sense. Yeah.
Yeah.
Is that any easier though? 45 times 3.6? I wouldn't do it that way. It's the same math, right? Same exact arithmetic. I would do the 0.45 because you're not really taking 360 and moving the decimal place. You're keeping that 360. You're taking that percentage, 45%. Did you know what percent means? Percent. We said that of means multiplication, correct? In math, what does per mean? Divide by cent. What's cent? How many cents in a dollar? How many years in a century? It's 100. So what does percent mean? To do what? Divide by 100. All right? So watch. 45% means what? 45. What does percent mean? To divide by what? 100. And if you divide by 100, basically just means you move a decimal place, what? 2 places, right? And 2 places to the left since you're dividing. Make sense? All right, enough of that. This wasn't supposed to be a percentage lesson today, but that's okay. Let's do that. Let's do the rest. AEB, how would you find that? Yeah, but give me numbers. 0.5? 0.05. That's why I wanted to ask you. It's 0.05 times what? 360. All right, and that gives you 108. And you get the idea. All right, so this is what? 0.2 times 360, which is 72 degrees. And this is what? DEC is 0.3 times 360, and that gives you 18 degrees. What should happen with all 4 of these angles right here? They should add up to 360. Try it, and it does. Okay? Everybody with me? All right. So we did that for a reason. All right, kind of. Here's a little theorem. All right, and the theorem is basically a formula, and it's the area of a sector. I'll just put little sector down here. Understand what that means? Area of a sector, okay, is equal to. Now, what's the area of a whole entire circle? I'll tell you what, let's draw that just so you can visualize it. All right, what's the area of this whole entire circle? Didn't we do this yesterday? Yeah, it's what? That's it. It's pi r squared. Okay, that's the whole entire circle. Okay? Yes? What if, what's the letter for that? L. Okay. What if I did this? What if I put, just guessing where the center is, what if I did this and this? What is the area? I think there's a way on this program where I can actually shade that in. I got to remember how to do that. I'll have to look at how to do that sometime instead of doing this ugly shading right here. It would be so much nicer if I could do that. All right, anyway, you get the idea. That's a sector, isn't it? How do I find the area of that sector? What if I knew the angle? What does this look like? It looks a little more than 90, doesn't it? Let's say it's 100 degrees. Okay, this angle right here. I know you can't see it with all that shading in, but that angle right there is 100 degrees, all right? What if I wanted to find just the area of that piece of the pie? It's not going to be pi r squared, because pi r squared is the whole entire thing, isn't it? How much of the whole circle are we trying to find the area of here? How much of the whole thing? Not percentage. I don't know what the percentage is. This time I actually know the actual, said actual too many times, the degree, the central angle. I know the central angle is 100 degrees. How would I find the area of just this piece of the pie? It's just part of the whole circle. How much of the whole circle is that shaded in part? It's 100 degrees out of what? Out of 360 degrees. Would you agree? All right. And then what would you do? Pi what? R squared. Everybody with me? So, what did we talk about yesterday? I gave you some Greek letter. I gave you a Greek letter of the alphabet that represented, it's not alpha, what is it? Theta. We say theta. That's how I say it. That's how we're going to say it, okay? We say theta. So, watch what we could do. Theta represents the central angle. So instead of 100, I mean, every central angle is not going to be 100 degrees, obviously. All right, so what do we represent the central angle with? Theta over what? To find a sector. This is the area of a sector. Over what? 360, and then what? Pi r squared. Okay? I'm not going to put any units here because this degree, whatever the degree for that is, and this degree would do what, basically? Look, these degrees do what? They just kind of cancel each other out, right? You with me on that? Because this just gives you a fraction. That 0 cancels. This is 10 out of 360, or whatever that percentage is, right? Comes out to some decimal, and I can figure out what that percentage is, kind of go backwards from what we did on that example. All right, enough of that. That is something that you need to know how to do. It's not like you really have to memorize it, because right here you figured out, didn't you, how to find the area of that piece of the pie? Didn't you? If I knew that angle right there, it's 100 out of what? The whole entire circle, which is 360. So it's like that. Now watch. Let's do a couple that are pretty easy. What if, I think the center is about right there. Watch this. What if I went from there to there? Let's move it over just a tad. There you go. And what if I went from there to there? And I ask you to find the area of this sector. That is 90 degrees. I should have put the little box right there. Yep, it's 90 degrees. 90. So we're finding the area, by the way. Area is, but you're right, it's 90 what? Over 360. Because we're not finding the area of the whole entire circle, are we? We're finding an area of part of the circle. In fact, how much of the circle is 90 degrees? 1/4 of it. Exactly right. Everybody see that? That's 1/4. Look what happens to the 90 over 360. So it's what? Pi r squared. The zeros cancel. 9 goes into 9 what? Once. 9 goes into 36 4 times. So it is 1/4, isn't it? 90 over 360 is 1/4. So we are only finding the area of 1/4 of the whole circle. This is the whole circle, but we're finding what? Just 1/4 of the whole circle. Agreed? What if, we'll stop with this one and do another example, then we'll be done. Let me find out where the center is. It's about right there. What if I did this? And I wanted to find the area of this sector. So how much of the circle is that sector right there? It's half.
50%.
Okay, it's 50%. Okay, you could do that. Or what are we going to do? We're going to use fractions. So if this is a straight line right here, that is a diameter. So it's what? 180 out of 360, what? Pi r squared. Again, pi r squared is the whole circle. I'm only finding that much of the circle. So 180 over 360. And that should work out to what? 1/2. That goes once, that goes twice. There you go. So that is half of the circle. Make sense? All right. Now, if I had an angle like 37.2 degrees, I don't know what fraction that is. I just put 32.7 divided by 360 times pi r squared, and I'm good to go. Make sense? Yeah, that's pretty easy. It's almost self-explanatory. It's almost not even worth a theorem. Would you agree? Yeah, because I already know the area of a circle, so the sector is just part of the circle. It's whatever the central angle is divided by 360. We good? All right, let's do one example, and it's going to make you think a little bit. What was the third thing that we said we were going to do? We talked about circles, we talked about sectors. Today we have not talked about this. What? A segment. So what's a segment? Well, a segment is basically if I connect from there to there. Do you see all this stuff right here? That's a what? That's a segment. It's not a sector. A sector goes from the central angle, right, to the edges of the circle, to the circle itself. Okay. This part right here is a sector. Yes. Okay. So let's put a circle here. Let's make this a little bit bigger because we're going to write all over it. There we go. Make it super big. Let's put it right there. And let's put the center. Looks about right there. And what I'm going to do is this. I'm going to draw a thing to there. Draw it to there. And then to there. What are those last two lines I just drew? From there to there. What would I call that line segment? A radius, right. What about this one right here? It's a radius. So what's true about every single radius on this circle? They're all equal to each other. So what's true about this side and this side? They're equal to each other. You with me? Okay. So that helps. What do I call this angle right here? Call it the central angle. Okay. What I'm going to do is I want to find the area. Okay. So I want to find the area. And let's put some letters in here. P, Q, and R. I want to find the area of sector. Now, and we haven't talked about this, but to name the sector, basically I'm naming it by the central angle. All right, so what would that central angle be if I was to name it? Now, you could just say Q because there's no other angles coming out of it, but using 3 letters. Using 3 letters, what would this angle be? PQR, or you could go RQP, doesn't matter, but I'll go PQR. Everybody with me? Now, we name the sector. Remember, the sector is at this whole piece of the pie right here. Not just this little bit, that's the segment. What is it? It's the whole piece of the pie. We name it with the same letters that we use to name the central angle. All right, so if I name this angle right here PQR, what am I going to call this sector? Sector what? PQR, all right? And we don't have a special symbol or anything for it. We just write the word sector. Everybody got it? So if I said, find the area of sector PQR, what are you finding? You're finding that whole thing right there. We good? All right, let me see what they give us. Is that 84 degrees? Anybody got their book open? Is that 84, the whole thing? Okay. So that's 84 degrees. My handwriting on my notes are a little sloppy. So let's find the sector. How do I find the sector? We just had a theorem about it, right? The area of a sector is what? The central angle divided by 360. So what's my central angle? It's 84 over what? 360. They tell you something else too. They tell you that's 3 centimeters. All right? Got to know the radius. And then it's what? Pi. What number are we using for pi? 3.14. We're not using the pi button on the calculator. We are going 3.14 times the what? Radius squared. So what's the radius? It's 3, and I'm going to square that. If you put all that in your calculator, tell you what, let me just do it. I just want to see. I'm pretty sure that on my notes I used 3.14, but let me just double check. Because I didn't write in 3.14, I just put the symbol pi. So 84 divided by 360 times 3.14 times 9, right? Because 3 squared is 9. Yeah, 6.594, but the 9 rounds the 5 up to a 6, so 6.6, all right? Now, I really shouldn't put equals, wouldn't mark off or anything. I'm being super picky here. But technically, 3.14 is a what? It's an approximation, isn't it? So really, let's put a squiggly equal sign, all right, if we want to be really careful about this, all right? And it's 6.6. It's not an exact answer, okay? It's an approximate answer. Yes? All right. What's my units? Centimeters squared, because I am finding the area. So that's the area of the whole entire thing. Got it? That whole entire, watch.
Daniel Jackson's office. Thank you.
Okay, of that whole entire thing right there. That's what we just found. We found the area of that. Make sense? Yeah, that was easy. I was nothing any more difficult. But now it gets a little trickier, because now we are going to find the area of the segment. Now, we just use 2 letters for this. Okay, it just represents the area, what do they say, bounded by these 2 points. All right, look at P and R right there. You see this? That's your segment. So now we want to find the area of that shaded in part. I'll keep that shaded in. Okay, so what are we going to call the segment then? Just use the 2 points. Use that line segment that makes that area, I guess. I don't know how to say it better than that. What are we going to call it? Segment what? PR. Yeah, let's just call it segment PR. So that means from P to R, this part along the circle and that straight line, okay, that's what we're trying to find the area of. We haven't talked about that. We didn't have a theorem for it, but you could figure it out. What do you think? What are we going to do? What's the thought process? We already found the whole entire sector, didn't we? 6.6. We're going to use that. So how do I find out this little bit right here? Are you thinking, or are you just waiting for me to answer? I see a couple people looking like they're thinking. How am I going to find that? I don't need like a formula. Just give me like a basic idea. What's your thought process? Remember, we already found the area of the whole entire sector. So this whole thing, this whole piece of the pie. There you go. That's what I was looking for, okay? So watch. We already found the area of the whole entire sector. This is what's left over if you know the area of the triangle. If you take the triangle out of that sector, this segment, this stuff right here, is what's left over. Do you see it? Okay, so what I'm going to do is I'm going to get rid of or subtract this triangle from what? From the whole thing, which was what? What was the number of the whole sector? We already found it. 6.6, that's right. So we're going to take that triangle and we're going to subtract it from 6.6. So all you have to do is find the area of the triangle. Let's do that. Let's go different color. Got too much white going on here. So here, I'll give you a little hint. What we're going to do is we're going to take a perpendicular line from the center to that chord, that PR right there. All right, so I'm going to go perpendicular to it. Okay, so what do you think is going to, I'm not going to go through all the reasons, but what do you think it does to that 84 degrees? Okay, it bisects it. Tell you the truth, I don't even think we're going to need that. Oh, you know what else I didn't tell you? Sorry about that. That PR right there, let's just write this down right here. PR is 4. Can't believe it. I thought I wrote down everything on that thing, but I didn't. So from P to R is 4. Okay, so it does bisect that angle, but it also bisects this chord right here, this PR. So, yep. So what is, I don't know, let's call this, what do you want to call that? PQR. Let's call that S, all right, PQRS. All right, if that's S right there, what is SR? It's 2, that's right. So that little bit is 2 centimeters. Everybody got it? The whole thing is 4. Right? So that's 2, that's 2, that's 3, you get it. What's true about these triangles? They're congruent to each other. All right, so anyway, what am I going to do to find the area of the triangle? Well, what is the area of a triangle? Exactly right. It's 1/2 the base times the height. Okay, let's take a look at what I know here on this triangle. Do I know the base? Do I know the base of the triangle? Yeah. What is it? It's not 2, it's 4. It's the whole triangle, okay? Do I know the height of the triangle? Don't. That's the work, okay? That's what we really have to find is the height, okay? So what I'm going to do now is I'm going to look at just this right triangle. Remember we said that's perpendicular, so that's a right angle. Look at this triangle right here. How am I going to find that? Pythagorean theorem, that's right. See how all that stuff comes back? We learned it before, it all comes back and we put it into good use, okay? So over off to the side, let's do a little Pythagorean theorem and solve for the height. I know the base already. I know what 1/2 is, all right? I just have to find the height. And I find that because I've got a right triangle, I know a hypotenuse, I know one of the legs, I got to find the other leg, which would be the height. We good? Let's do it. How do I set it up? Good. H squared plus 2 squared equals 3 squared. Everybody see it? Those are my 2 legs. 3 is the hypotenuse. I put that by itself. A lot of people would put, how did we learn it? Well, now we learned it like this, didn't we? A squared plus B squared equals C squared. So that's perfect. Let's do the math. Let's do it quickly now. H squared plus what? 4 equals 9. Subtract 4. So H squared is 5. What's H? The square root of 5. So that's the height. Now, we're almost ready to find the area of the triangle. But we're not done the whole problem, though, just because we find the area of the triangle. We still have to take the triangle, subtract it from the 6.6. But that shouldn't be that hard, okay? So let's find the area of the triangle. Area of the triangle. So it's 1/2. The base, what do we say the base of the whole triangle, the whole entire triangle? It's 4. And what's the height of that triangle? It's the square root of 5. It's weird, but that's okay. We got a calculator. We could put it in. If you want to make this a little easier, let's go 1/2 of 4. What's 1/2 of 4? 2. So it's basically 2 squared of 5, the area, isn't it? That's the triangle. But what are we trying to find? We're trying to find this whole entire segment. All right? So let's write this down. I mean, we could think this in our head, but I'm going to write it down anyway. The area of the segment, I want to get real general right here. To find the area of the segment, what do? We find the area of the what first? The sector, which we already found, minus what? The area of the triangle. Okay? Everybody, you understand that part, right? I just want to write it down so you can see it. So now, I tell you what, let's go a different color. So now, let's do it. The area of the segment. Oops, wrong key. What was the area of the sector? 6.6 minus whatever. I think this reduces to around 4.5. Like if you stuck that in a calculator, you would get approximately 4.5. Again, these are approximate answers. These aren't exact answers. So it's 6.6 minus what? 4.5. Does the 4.5 make sense? Yeah, because it's less than the 6.6. What if I worked out that area of the triangle and I got like 17 something? Would that make sense? It wouldn't, because the triangle has to be smaller than the whole entire sector, because the triangle is just part of the sector, all right? So do the numbers make sense to us? Yes, absolutely, all right? So the sector is bigger than the triangle, okay? And now you just work that out. That's easy. That's what? 2.1. Actually, I should put a little squiggly. They should all be squiggly, all right? So 2.1, we are finding area. So what is the units? Centimeters what? Squared. There you go. That's how you find the area of a segment. It's not super straightforward. It's basically in two parts, all right? Find the area of the sector, which is the whole piece of the pie. Then you take away the triangle, right? So you got to find the area of the triangle, though. You find the area of the triangle. You take the triangle away from the sector, and that gives you the what? The segment. And that is the area of all of this stuff right here. It's approximately 2.1.
Is there a way to find the segment without the segment?
Nope. You'd have to find the whole entire sector. All right? Or they tell you the whole sector, right? They could tell it to you, okay? But you'd either have to be told or be able to find the whole entire sector. Then you find the triangle. And again, they could have told you the triangle. But on this one, they didn't tell you either one of them. And that's probably what they're going to do most of the time, all right? You're going to have to find the sector, find the triangle, take triangle away, and then you got what's left over. This is just basically leftovers right here, the segment, all right? That's what you're finding. We good? That's it. That is section 7.6. So, you got the lesson plan in front of you, don't you?
Yeah, 13 to 18.
So it's 13. I was originally going to give you 13 to 18 yesterday, but it didn't quite get there yet. But now we should be able to do it. Okay, it's 13, 18, and what was the last part?
19.
Okay, so it's basically 13 to 30. Okay, you have it on the first part. Ugh. I really wanted it. So you have 13 to 18 on the first part. How'd you know how to do 13 to 18? Did you look it up? Okay. I guess I don't want you to have to rewrite it again, but just when you turn in part B, just say I put 13 to 18 on part A, just so that I remember, because I probably won't remember unless I see that. All right, everybody good? No questions? All right, look, you have got to watch, I'm telling you, because you're going to have problems on the test. And the test is what?
2 days.
Thursday? All right. So watch last year's video. I'm holding my ground on this, okay? I got 5 minutes. I could probably start teaching it, maybe even tomorrow. But I'm holding my ground because I've told you twice now. This is the third time. Would you agree? This is the third time I've told you to watch the video of section 7.5 from last year. Okay? You don't have to watch the whole entire thing. Go to the part that we didn't cover, all right? So get your notes out for 7.5, scan through the video, and you're like, okay, we covered that. Oh, this part's new. And then just watch that. It's probably, my guess is, I don't know, I haven't looked at it, but it's probably only like 10 to 15 minutes, maybe. Okay? It's only 5? There you go. So it's only 5 minutes, all right? You got to watch. So watch it, all right? For goodness sakes. We're in the computer age now, all right? You guys are acting like you can't get on your phone for 5 minutes, okay? You're on your phone for hours and hours and hours. Okay, take 5 minutes and put some good use to your phone, all right? And watch the end of that video. Everybody got it? Okay. Enough said. Have a good day.